All right, so in this section, we're going to talk about metric conversions. So on the formula sheet, you are going to see this table, which has metric prefixes and the factor that they represent. The thing is, in this chapter, you're going to hear the words nano, you're going to hear micro, and you're going to hear pico. Micro, by the way, is this Greek, it looks kind of like a funny looking U. You have to have a kind of an understanding that these are very small, very small units. A micrometer is a millionth of a meter, or basically a thousandth of a millimeter. So if you think of the little spaces on a ruler, you know that how close they are, those are millimeters. So a thousandth of one of those is a micrometer. And a nanometer is a thousandth of that, and a picometer is a thousandth of that. So they're very tiny, but when we're talking about tiny things like cells, those units make sense. However, it would be expected that you could freely convert back and forth between these units. And given this table, a lot of people are kind of iffy with their metric conversions and don't know how to convert between the units from the information that's presented in this table. So I want to clarify what information the table is actually giving you. So you'll notice, for example, giga. So, and the factor here of 10 to the 9th. What that means is that 1 gigameter is 1 times 10 to the 9th meters. Look at kilo. 1 kilometer is 1 times 10 to the 3rd meters. In other words, this factor is basically how many meters each of these units represents. So if you were going to do a metric conversion, you can set up dimensional analysis. And I have a couple of examples here. Let's just say, for example, you needed to convert from kilometers to picometers. Well, there's nothing on this table that converts directly from kilometers to picometers. But I can relate them to each other using meters. I find kilo, and I know that a kilometer, 1 kilometer, is 1 times 10 to the 3rd meters. And I can find pico on here and see that 1 picometer is 1 times 10 to the negative 12th meters. Now, I could convert from kilometers to picometers, although it would take 2 steps. Now, there are more efficient ways to do this, and if you're really good with conversions, and if you're really good with working with exponents, you do not have to do it this way. But I wanted to show you, bare bones, how you can use this table to do a conversion. So if I wanted to convert, let's say, 2.5 times 10 to the 3rd kilometers, and I wanted to convert it, let's just say, to picometers. My first step would be, notice my 2 conversions, I'm going to go from kilo to meter. So 1 kilometer is 1 times 10 to the 3rd meters. If I stop here, I've now converted to meters, but I can keep going. And my second conversion would be 1 times 10 to the negative 12 meters is 1 picometer. And I have basically converted from kilometers to picometers using the conversion factors on the table. And then how would I actually solve this? I would plug this into my calculator, 2.5 times 10 to the 3rd times 1 times 10 to the 3rd. And then take your answer and divide it by 1 times 10 to the negative 12th. So 2.5 times 10 to the 3rd times 1 times 10 to the 3rd divided by 1 times 10 to the negative 12th, and you would get your answer. So in class, we did 3 practice problems. I will show you the first one here. So I want to go from millimeters to nanometers. So if I go to my table, which I don't have up here, but it's on the formula sheet and you should have it in the outline, I will find that 1 millimeter equals 1 times 10 to the negative 3rd meters. And I will also find that 1 nanometer is equal to 1 times 10 to the negative 9th meters. So I got those from the table. Once I've got those factors, I can now set up dimensional analysis. So 250 millimeters times, I want to cancel millimeters, so 1 millimeter is 1 times 10 to the negative 3rd meters. Millimeters will cancel. And then my second conversion factor, now I need to cancel meters so I can get to nanometers. So 1 times 10 to the negative 9th meters is the same as 1 nanometer. And now meters will cancel. And if you plug that into your calculator, So you would do 250 times 1 times 10 to the negative 3, then divide your answer by 1 times 10 to the negative 9th, and your calculator may or may not give this to you in scientific notation. It might give you this, 250 million, or it will give you 2.5, times 10 to the 8th, and that was nanometers. And technically you really should put it in scientific notation, but either of those answers theoretically is the correct value. All right, for the second one, it's just a one-step problem because I'm going from micrometers, that technically is what micro should look like, straight to meters. So we only need one conversion. M by itself is just meter. If you go to the table, you will find that 1 micrometer is 1 times 10 to the negative 6 meters. And so we would literally do 0.055 micrometers times 1 micrometer is 1 times 10 to the negative 6 meters. Oops. And plug that into your calculator. You're basically just going to multiply there, and you're going to get 5.5 times 10 to the negative 8 meters. And that would be our second one. All right, for our last one, let me clear the work off here. I go to my table. I need to get the conversion for gigameter and for centimeter. So for gigameter, if I go to the table, I find that 1 gigameter is 1 times 10 to the 9th meters. And I find that 1 centimeter is 1 times 10 to the negative 2 meters. And again, I'm getting this straight from the table that you would be provided with. And now I can set it up. So 1 times 10 to the negative 7 gigameters times 1 gigameter on the bottom so that it cancels is 1 times 10 to the 9th meters. Now I need to cancel meters to get to centimeters. So 1 times 10 to the negative 2 meters is 1 centimeter. I'm going to do 1 times 10 to the negative 7 times 1 times 10 to the 9th divided by 1 times 10 to the negative 2, and you will get, your calculator may just give you 10,000, or it might give you 1 times 10 to the 4th, and again, our units here are centimeters. So again, I am not saying that you have to solve the problems this way, but your short answer will include 3 metric conversions. You're also going to do 6 metric conversions in the lab we're going to be working on. And so I'm just trying to present you with one way that you can use the table that's provided to you to solve these. If you know your metric conversions, or you are really good with exponents and you understand how to just move the decimal back and forth, you can do that. You do not have to use my method. But hopefully this gives you one way that you can solve these, particularly if you haven't had chemistry in a long time or you're not great with working with conversions and exponents.